Hi, in this video I'm going to take a look at confidence interval of the sample mean. So this is the first problem that we're going to concern ourselves with, and this is from section 10.4 in the textbook. So let's take a look. Our population has a mean and standard deviation of 12. We don't know what that mean is, but it's okay because we have a random sample of 800 from this population, and that sample has a mean of 63. So we have to find 95% confidence interval for the population mean. So let's write down what we know. We know that standard deviation is 12. So my sigma equals to 12. I know that number of items in the sample is 800. And I also know that sample mean x bar equals to 63. So for the sample mean, the margin of error is given by 1.96 multiplied by standard error of the sample mean, which is the same as 1.96 multiplied by sigma divided by root n. And for our sample, this turns to be 12 divided by root of 800, which turns to be 0.424. Okay, so that's my margin of error. And then to construct the confidence interval, the 95% confidence interval, all I need to do is take the mean of the sample and take away the margin of error, and that's going to be less than actual value of the population mean, which is less than mean of the sample plus the margin of error. Substituting the values in, that's 63 minus 0.424 less than population mean less than 63 plus 0.424. So calculating this out, I get that the lower limit of the confidence interval is 62.576, and the upper limit of the confidence interval is obviously 63.424. So that would be my 95% confidence interval. Next question, I can't remember the number of the question, and I apologize for not having it put down here. So we have 70 packs of butter selected at random from a large batch delivered to a supermarket are weighed. The mean weight is found to be 227 and standard deviation is found to be 7.5 grams. Okay, cool. So we're going to say that we have 70 packs of butter, so n equals to 70. Mean of the sample x bar equals to 227, and the standard deviation sigma is equal to 7.5 grams. So we have to calculate the 95% confidence interval. So first I'm going to find my margin of error, 1.96 sigma divided by root n. So in this case, this is going to turn to 1.96 by 7.5 divided by root of 70. So when I calculate that, this is 1.756. Cool. So then, to find the margin of error, the confidence interval for the population mean, this will be equal to x bar minus e, again less than population mean less than x bar plus margin of error e. Substituting the values in, that's 227 minus 1.756 less than the mean less than 227 plus 1.756. So that is going to be 227 minus 1.756 which is 225.244, less than the mean, less than 228.756. Cool. So that's my 95% CI. If one pack is selected at random from the 70 packs, find the probability that its weight is not in the given interval. So we can expect, my expectation will be that 95% of every item in the sample is in the range, and that means that 5% are out. So if 5% are out, then the probability equals to 5%. So I'm expecting that 5% of that it will be, sorry, if one pack is selected at random, it's 5% probability that its weight is not in the given interval. So then question 5, the weight of vitamin E in the capsule manufactured by the drug company is normally distributed with a standard deviation of 0.04. Random sample of 12 capsules was analyzed and the mean weight of vitamin E was found to be 5.12 milligrams. Find the confidence interval, 95% CI. Give the values of endpoints of the interval correct to 3 significant figures and explain what is meant by 95% confidence. So we're expecting that 95% of the sample means taken out of this population would be within a predicted range, would be within the confidence interval. So that's that's the meaning of the confidence interval. We are expecting that 95% of the sample means taken out of this population would be within that interval. So let's write down what we know about this problem. My n is equal to 12, my mean is equal to 5.12, and my sigma is equal to 0.04. So then standard error can be calculated to be equal to 1.96 root of, sorry, that's population proportion, rather 0.04 divided by root of 12. So that turns to be 1.96 multiplied by 0.04 divided by root 12, which is 0.023. So then the confidence interval is equal to sample mean 5.12 minus 0.023, 5.12 plus 0.023, which then will turn to be 5.12 minus 0.023, 5.097, which is less than 5.143. That's given to correct to 3 significant figures, and these values are the values of endpoints. Okay, so we have 95% confidence interval for the mean mark of a group of students is within this range between 54.09 and 60.71. The interval is based on the random sample of 80 students. We have to find the mean of the sample and then the standard deviation. So I know that confidence interval is constructed by taking the mean of the sample, taking away the standard error, it's less than the mean of the population, and take the mean of the sample and add the margin of error rather than standard error. Let's say that this limit and this limit, I'm going to give them specific names. Let's call this B and let's call this A. And I know that B minus A can be written as x bar plus E minus x bar minus e. So if I simplify that, that gives me x bar plus e minus x bar and then plus e. So these two quantities cancel and I'm going to get twice the margin of error. So the difference between the values of the endpoints is twice the margin of error. Let's use that fact for this problem. So I know that value of b, which is the value of the upper endpoint, is given to be 60.71. So let's say 60.71 minus 54.09 equals to 60.79 minus 54.09, that equals to 6.7. And that is also equal to twice the margin of error. So from here I can get that E is equal to 6.7 divided by 2, which is equal to 3.35. So that's my margin of error. And then I know that upper endpoint 60.71 is the same as x bar plus 3.35, x bar, or the sample mean, plus the margin of error. So that leads me to think that 60.71 minus 3.35 is the same as the value of the sample mean. And that value is 57.36. So that's the value of the sample mean. And I also know that margin of error E is the same as 1.96 multiplied by sigma over root of n. So trying to find standard deviation from it, let's transpose the formula a little bit to get sigma being equal to a margin of error multiplied by root of the number of the items in the sample, and all that divided by 1.96. So the question tells me that the n size is 80. So substituting the values into my equation, I get that 3.35 multiplied by root of 80 and all that divided by 1.96. That will give me the value of the sample standard deviation. So let's chuck it into the calculator. 3.35 multiplied by root of 80 and all that divided by 1.96. That is 15.29. And that's the value of the standard deviation of the sample. And that's the last problem in the sequence. So thank you for watching.